Good morning and welcome to another episode of Geology Hikes with Thomas. Today's topic is going to be the Virgin Anticline. We're looking here west, snow-covered Pine Valley Mountain, red rocks in front of it, so it must be southwestern Utah. Well, let's start the explanation. An anticline is formed by compression of sedimentary layers. Let's figure the hands are sedimentary layers. There is pressure from one side or from both sides, or resistance from one side, and the layers start buckling up, forming a bulge. It can be quite big, and that's what's called an anticline. Well, the bulge can be also downwards, and then it's going to be called a syncline. A while ago I took a photograph of a small anticline and syncline a little further south in Washington fields, and here you can see nicely the anticline, the bulge upwards, and adjacent to it the syncline. That's how sedimentary rocks react to pressure compression from the sides. The anticline is about 20 miles long and up to 7 to 10 miles wide. The Virgin Anticlines has a lot of interesting features. Dinosaur tracks, you find silver mines, you have petrified wood, you have nice fossils. How can sedimentary layers bend? The answer is simple: heat. If you heat it up a couple of 100 degrees, then you can bend the layers. It's just like Hershey bar chocolate. When you take it out from the refrigerator and try to break it, it snaps. That's what's called brittle deformation. But if you put it in your pocket, it doesn't melt, it softens up. That's the key, and then you can bend it. That's just how this rock is being bent here. Now the top has sometimes cracks. That's where erosion sets in and digs down deep into the anticline, exposing the different layers. And you can see there's a very gentle curved hill here. That's one of the surfaces of the layers. It's called the Chinarump Formation, part of the upper Triassic, which is exposed here. Whitish, what's called here reef, rock faces sticking out. That's where you can find silver, and you can go all the way up past the red rocks to the white rocks, not in the snow, the tree covered ones. That's all part of the anticline that has been opened up, so you can look at a kind of a cross section of the layers. And again, if you swing around, you see a blind arch just across here. It's all part of the anticlines with the layers of the rocks sticking out, and basically have the same inclination as the rock face you're standing on. We're going to climb up a little higher up to the top and see if we can see the east part of the anticline, which should be just the same layers, only tilted in the opposite direction. Remember, it's a bulge, it's a long bulge. We reached the top of its layer here, can't go any further. Just looking back where we came up, you can see the blind arch across the valley to the west here. Again, the Pine Valley Mountain, the different rock layers of the open cut anticline, the white silver reef sticking out there, and as you go across, we pick up more rock layers slightly bent straight across at the horizon. That's the same layer as you're standing on. You can see it here as well. That's the Chinarump sandstone, a braided river deposit, and we can follow the contours of the layers, and as they turn, they start sloping down to the right. So that's the center of the anticline. In the back you can see Zion, West Temple, a gorgeous early February day here. Well, sometimes you find some plant fossils here, like here. It's probably plant. Here, some more fossilized plant material. Well, it's time to turn around, but let's have a last look here. We go up, and then you have the erosion of the center core, steep drop down, you see the rock bands. And now we pick up the layers on the other side of the lake, pointing towards us. We see only the rock faces. We don't see the gentle slope leading up to those rock faces. It's just nice, the mirror lake and everything here. Who wouldn't want to be a geologist here in southern Utah? I call it naked geology. You see all the layers here at the center of the anticline, and then the western flank again. As you swing around, you see the red bands. That's the transition to the lower Jurassic. On top we have the sandstone cliffs of the Navajo sandstone, same sandstone present in Zion. Behind you can see some layers with lots of trees on them. That's the Cretaceous formation. So the anticline spans roughly 160 million years with gaps in between. I do hope you enjoyed this show, and stay tuned for the next part, which gets us more into the landscape details and the interesting geological feature in more detail. Thanks for watching.